Hello, this is the lecture number 2 for the chapter matrices of class 12th, and we're discussing the first exercise. In question number 8 of this exercise, it is given that this is a square matrix. Then what will be the relationship between M and N? Then when it is a square matrix, you know that the number of rows and number of columns are same, so therefore M will be equal to N. In question number 10, it being asked, there is a matrix of order 3 by 3 and the elements of this matrix is only 0 and 1. Then how many matrices you can make? Now we have 9 elements in this and we have only 0 or 1 you can place. So it means for each place we have only 2 options, that is 0 or 1. So you know, by fundamental principle of accounting in class 11 we have done. And now we have 9 places, and for each place we have 2 elements, 2 options. So 2 into 2 into 2 into 2 up to 9 times, that is 2 raised to 1 9, that is 512 matrices we can make. For example, all the element of this matrix can be 0. All elements of this matrices can be 1. You can place here 1 and all elements 0. Place here 1, remaining 0. So like this, you can make 512 matrices for this matrix 3 by 3 order, and whose elements are only 0 and 1. 512 matrices you can make. Now after that we have operations on matrices. Now what is operations on matrices? Operation on matrices means you have to add or subtract or multiply a matrix by a scalar or multiply the matrices. This is known as the operations on matrices. First is addition of matrices. Now when we can add 2 matrices? Now we can add 2 matrices only if their order is same. Now suppose we have this matrix A whose order is 2 by 3, and there's another matrix B whose order is 2 by 3. Now we can add these two because the order of these 2 matrices are same, and we can add. How can we add? When the matrices are same and we are adding it, then we have to add the corresponding elements. Corresponding elements means we have to add A11 with A11, A12 with A12, and so on. That is corresponding elements you have to make. So it is a simple, and similarly you can subtract. Now the scalar multiplication of the matrix by element scalar A. Now what this means? Now if you have matrix, suppose there is a matrix A 1 2 3 minus 1 0 2, and you have to find 2 minus 2A. This means that you have to multiply the matrix A by a scalar minus 2. That is, you have to multiply all the elements of this matrix by this minus 2. That is minus 2, 4, minus 6, 2, 0, minus 4, like this. Now suppose we have matrix A and matrix B, and you have to find 2A minus 3B. Now what this means? It means that you have to multiply the matrix A by 2, matrix B by matrix B by 3, and subtract matrix B by 3 and subtract. So multiply the matrix A by 2, matrix B by 3 and subtract. So multiply matrix A by 2, matrix B by 3, multiply, and then subtract. Subtract means you have to subtract the corresponding elements as we have to do in case of the addition of matrices. Now after that we have an important topic of the multiplication of the matrix, multiplication of the matrices. Now it is an important topic. Now how can you multiply the multiply the 2 matrices? Now the multiplication of the matrices is not always possible. It is only possible when the number of column of the first matrix is equal to the number of rows of the second matrix. Now suppose we have a matrix A of order n by p. There's a matrix of order matrix B of order p by m. Then they can be multiplied because the number of columns of the first must be equal to number of rows of the second. Possible only if this is equal to this. Or if we have a matrix of order A of order m by n, there's a matrix of order B of order p by q, then n must be equal to p. N must be equal to p, and the order of the resultant matrix will be m by q. M by q, this is the main, you have to learn this. The order of the resultant, this will be because n is equal to p, then m into q will be the order of the resultant matrix. Now I'm taking the example. I've taken this a matrix 1 minus 2 3 minus 4 2 5, or its order 2 by 3. Then I've taken a matrix 2 3 4 5 2 1 and its order 3 by 2. Now because the order of number of column of this matrix first is equal to the number of rows second, so we can multiply these two matrices and the order of the resultant matrix will be 2 by 2. Be very careful, 2 by 2. So first of all, write the order of the resultant matrix, then you have to multiply. Now if I take this example, this is a 1 2 3, this is a matrix of order 3 by 1 and second matrix is of order 1 by 3, because the number of columns of the first is equal to the number of rows, which is 1, and the order of the resultant matrix will be 3 by 3. See it very carefully. Now how you have to multiply, see it very carefully, because the product of these order of the product of these two matrices is 2 by 2, so 4 elements will have. Now what is the first element? To obtain the first element, you have to multiply the first row with the first column. First row, first column, multiply and add. So 1 into 2 plus minus 2 into 4 plus 3 into 2. Corresponding, you multiply like this. First row, first column, 1 into 2, minus 2 into 4, 3 into 2 and add. This is the first element you'll get. Multiply the first row with the second column, you'll get the second element. That is 1 into 3, minus 2 into 5, 3 into 1 and add. Like this. Second row, first column, as the row changes in the first, the row of the resultant matrix will also change. So multiply minus 4 with 2, 2 with 4 and 5 with 2 and add. You will get this. Minus 8 plus 8 plus 10, this. Then multiply second row with second column, minus 12 plus 10, 5 into 1, that is 5. So minus 12 plus 10 plus 5, this. And simplify, you will get a matrix 0 minus 4 10 3, or order 2 by 2. You first of all find the order of the resultant matrix. Similarly here, I have taken the example 3 by 1, 1 by 3. The order of the resultant matrix will be 3 by 3. So we have 9 elements. So first multiply first row with the first column. We have only 2 and nothing we have to add. First row, second column, that is 3. First row, third column, that is 4. Second row with first column, which is 4. Second row with second column, which is 6. Second row with third column, which is 8. Third row, first column, third row, second column, third row, third column. Like this, you have to get the matrix. Now if we interchange it, if I interchange it 2 3 4 2 3 4 and 1 2 4, first of all we'll find whether we can multiply these two matrices or not. Now because the order of this matrix is 1 by 3 and the order of this matrix is 3 by 1, because the number of columns of this matrix is equal to number of rows, so we can multiply and the order of the resultant matrix will be 1 by 1. This is the important thing, you have to note it down. First of all, the order of the resultant. First row, first column, you have to multiply and you'll get only one element, that is 2 into 1 plus 3 into 2 plus 4 into 3, that is 20. 1 by 1 matrix will be there. So what we conclude? We have concluded that A cross B is not equal to B cross A. If this is A into B and this is B into A and they are not equal to each other, it means that the multiplication of the matrices is not commutative. Now if you have to find the A square, so A square, it means A into A. That is, you have to multiply the matrix A with matrix A, and you can easily multiply it because this is a matrix of order 2 by 2. It is a matrix of order 2 by 2. So you can easily multiply because the number of columns is equal to number of rows. So we can multiply it. So this is the important topic for the multiplication of the matrices, and you do at least 4 to 5 questions of the multiplication so that you have a good command over these types of questions. Now we are starting with the exercise 3.2, and in question number 1, first 2 3 parts are very simple. You have to add or subtract the matrices. Now in question number 1, I am taking the in third or fourth part, you have to find the A into B or B into A. Now A into B, the matrix A is given 2 4 3 4 3 2, and the matrix B is 1 3 minus 2 5. Now this matrix is order 2 by 2 and this is also of order 2 by 2 because the number of column of this matrix is equal to number of rows of this matrix. So we can multiply, and the order of the resultant matrix is 2 by 2. So first of all, write the order of the resultant matrix, which is 2 by 2. So how can you obtain this? First row, first column means 2 into 1 plus 4 into minus 2, that is 2 minus 8. First row into second column, that is 2 into 3 plus 4 into 5, that is 20. second row first column, that is 3 into 1 plus 2 into minus 2, second row second column, that is 3 into 3 plus 2 into 5. You'll get the elements of this matrix of order 2 by 2, which is a resultant matrix. Similarly, you can find B into A. So B into A, number of columns is equal to number of rows of this matrix. So we can multiply it, and the order of the resultant matrix will be 2 by 2. So first row first column 1 into 2 plus 3 into 3. This is first row second column 1 into 4 plus 3 into 2, that is 6. Second row first column minus 2 into 2 plus 5 into 3, that is minus 4 into 15, and minus 2 into 4 into 5 plus 5 into 2, that is the 8 A to 2, the second row and second column element. Now A into B is not equal to B into A, that is the product of the matrices is not commutative. In question number 5, it is 3, you have to find 3A minus 5B. So 3 into A in minus 5 into A, this is matrix A is given in the question, matrix B given in the question. So multiply all the elements by 3, multiply all the elements by 5 and subtract 2 minus 2, 3 minus 3, 5 minus 5, 1 minus 1, 2 minus 2. So you are getting a null matrix here. Now in question number 7, x plus y is given equal to 7025 and x minus y it is given as 300 minus 5. You have to find the matrix x and matrix y you have to find. Now if we simply add these two, add step number 1 and 2, so or subtract step number 1 and 2, so minus plus minus, x will be cancelled out, so y plus y 2y, subtract this matrix from that, 7 minus 3, 0 minus 0, 2 minus 0, 5 minus 3. This is the matrix and divided by 2. So we have subtracted this, subtract these two. So I am getting the y as 2, 0, 1, 2. Now if we put the value of matrix y in either of the one equation, I put it in the 1 and take this to the right hand side, they will get the matrix x, that's 5, 0, 1, 4. So this is the question number 7, and one part also we have in this question like this. You have to solve it simultaneously. Okay, we will discuss the remaining question in the next lecture. Thank you.